Hello everyone, today we're going to build an advanced ledge locomotion system in Unreal Engine 5 that really took me years to develop. This system is going to make your character to detect the ledges and interact with them in a really smooth and responsive way. In this tutorial, we're going to learn how to set up the ledge stripes so that you can place on your level, and your character will use them as a reference to detect where the ledges are located. So once the character is attached on the ledge, you will be able to press F to grab or release the ledge. Use the directional input keys of your keyboard or gamepad to move in any direction while hanging. And you can also place the ledge in any place that you would like in your game level, as it is completely modular and the character will automatically, of course, make the calculations necessary to complete the movement in a smooth way, no matter the distance and the angle. This tutorial is designed to give you a solid base system that you can implement into your own project. It's modular, easy to expand, and you see how we handle things in the code like ledge detection, input management, and smooth animations. So by the end, you have a fully working system that you can keep building on and adding new features, of course. And now if you want to go even further, I already have a complete advanced ledge locomotion system available on my Patreon page. That version includes a lot of extra features such as corner transitions, inner and outer corners, climbing on top from ledge idle, dropping down to ledge, advanced freehang, leap transitions, and much more. So if you're looking for a polished production ready system, you can check that out through the link below. But for now, let's just dive in and start building the ledge system step by step so that you can understand the logic behind it and then decide how far you want to expand it on your own game. Just remember that you need this animation pack that I'll be placing the link in the description below so that you can follow the tutorial. Alright, now we're going to start by opening up the Epic Games launcher. And then here we're going to scroll down and see if you have the game animation sample. If you don't have it, you can search it on the marketplace. So here I'm going to create the project, and then here I'm going to select the folder. After I select the folder, you can click on create. Now, after the project is downloaded, we can download the next pack, which is the ledge climbing system animation pack. And here, as you can see, if you click on it, so as you can see, it's this one. I'm gonna also put the link down in the description below so that you can access it. So all you gotta do, once you buy that project, all you gotta do is just add it to your project. So here you're going to click on add. And then here we're going to select the project that we've just made. Mine is called Game Animation Sample. Of course, there's a lot, but I think as soon as you create one, once you create the project, if the project is new one, there's not going to be a thumbnail, so you can click on that. So as you can see, you can check the path and just click on Add to Project. After you've downloaded the game animation sample project and the ledge, we can just click to open the project. So if you go to the content folder, you're going to be able to see that we have the climb ledge animation pack, and we have all these FBX files. As you can see, you have all the animations needed for the tutorial. It's more than enough. It's more than enough, but in the future we can use all those animations to basically make a complete version of the system. All right, so here you have the game animation sample. There is nothing in the project, as you can see. If I just have the normal controls of the project. So what we're going to do first is we're going to prepare the environment so that we can work with the ledge climbing system. We're going to be going to the file. We're going to go to the edit and then go to the project settings. We're going to go down to the collision. And here, you're going to add a new object channel. This is going to be something like ledge. And the default response could be to ignore and accept it. So that's going to make the engine identify which kind of object it is. And that's going to serve it so the way that works is that when you place the ledge stripes, the code is going to identify those ledge stripes inside the code, and the character will be able to, so the character is going to be able to detect those ledges. So as you can see in the project here, we have the climb animation pack available for us. We have these FBX files. You're not going to really need this folder at all. You can just ignore it. And here we're going to click on the UE4 mannequin. And here we have two folders, one for the root and one for the physics. You're always going to use for the root because you have the root motion. As you can see right here, we have all these animations. So all you're going to do is just select everything, right click, and retarget the animations. That's the first thing you're going to do. Now for the target skeletal mesh, you're going to select the UFN mannequin. Okay. So after you select the UFN mannequin, you're going to click on all these animations. Pay attention here that we have the physics. So one thing that I like to do, I don't want to retarget the physics of animation. So what I'm going to do is just delete that folder. I don't need it. So I'm going to delete it now so that we don't mess up. We don't mix everything. I think it's going to be better. All right, so after we deleted the physics folder of the animations that we don't need, now it's better and safer to do the retarget, the retargeting. We're going to select the UFN mannequin. And then we're going to export the animations. Click here on the client Ledge animation pack, create a new folder. We're going to name it to be UFN. This is just the process of retargeting the animations that we need to retarget and placing them where it needs to be. So the prefix, you can select it to be UFN underscore or underline. And then click here on export. So you're going to export all the animations to that folder. So as you can see, you can save everything. Click here on File, Save All, just to make sure that all the animations are saved. So when you click once on this animation in here, for example, we're going to have access to a lot of animations that we have already retargeted. So as you can see, the hands of the character are not that much. Sometimes they float a little bit, and sometimes they float too much. So for example, here, as you can see, this animation has a bug that the creator hasn't fixed. I've already told him that we have this bug, but he doesn't want to fix it. I'm not sure why. That's one bug that we have only for this animation, but anyways, we can ask the creator later to fix this bug. I think that's not going to be a major problem for now. So as you can see, we have all the animations already retargeted. So all you got to do now is just select everything again, Ctrl A and right click. And now what we're going to do is just going to make the montage out of them. But first, before making the montages, we're going to enable root motion in all of the animations. And the reason why we need to do that is because as we're going to use root motion for removing the capsule of the character when navigating on the ledges, which is of course going to make the motion of the character transitions on the ledge much smoother, we're going to do that. So here in the asset actions, we can go to edit selection in property matrix. So that's what that's going to do. On this option here is just going to make yourself be able to enable root motion for all the existing animations that you've pre-selected. So here you can choose to select the name. We're going to search for the option to enable the root motion. So as you can see, if you click on here, as you can see, it enables, it pretty much enable all the root motion for all the root motion options for all the animations. So that's going to be pretty much it. So all you gotta do now is just press Ctrl Shift and S to save everything. So that's going to save the options in here. So after that, you can close out of this. And now to check it out, if that worked, you can just click on any animation here and check this option here. Enable root motion is going to be enabled. You can check another animation to see if it's enabled. As you can see, it's enabled. So that leaves us to the next step, which is to create the montages out of the animations. So as you can see here, we have a lot of animation sequences, which they are represented by this greenish lining here. So we need a animation montage so that we can better play the animations on on the way we want. Um, we can play the animations with blend arguments such as blend in and blend out time. So we can specifically decide like how much of transition it should go from one pose to another. So that's why it's good to have the montages. So all I'm going to do is just select everything, right click and go to create and create animation montage. So we're going to save everything again. Control Shift, you can press Control Shift S to save everything. And now as you can see, we have the animation sequence and we have also the animation montage. So as you can see, there is a difference between one of them, between one and the other. The animation montage is represented by with a purple line in here, and the animation sequence is with the green line. So if you click on the montage, as you can see, we have another kind of window that appears that is a little bit different when you click on the animation sequence. So you have the asset details, you can choose the blend in time, the blend out time, you can choose the curves, like how much, how the character's animation should move from the A pose to the B pose. All right. So that's just the preparation of the animations. You're pretty much ready to play those animations. Now, the next thing I'm gonna do is going to be for preparing the light stripes. So what are the light stripes and why we need to set it up? Well, basically the light stripes are essential for making the character to detect the ledges. So here you're going to have the ledge, as you can see right here. And what I do in my system that makes the character to identify the ledge is the ledge stripe. So with the ledge here alone, it's not going to be, the character is not going to be able to identify because we need the ledge stripe as well. So we put the ledge stripe in here and there you go. The character can detect the ledge. But without the ledge stripe, as you can see, we cannot, even if we try to attach the character to force it, it's not going to go. So this way, I think it's the best way you can handle things, especially for the ledge stripe, especially for the ledge movement and ledge calculations, because we really need to have a solid reference of which angle we should go in order to not make the character to glitch through walls or float. So how can you do this ledge stripe? So what you're going to do is just go to shapes, go to cube, move it down. You're going to resize it. So as you can see, you don't have that much precision when you do this. So I'm going to just disable everything here so that we can precisely change the scale of the cube. So all we're doing here is just a ledge stripe. Just be sure to not make that much thin, I guess. Very much that. You can choose the material color that makes sense to you. I'm going to choose maybe blue. Makes sense. And what I'm going to do now, I'm going to get another cube that's going to represent the, let me see if I can try to make a, material. This cube here is going to represent the wall, and I'm going to also make the ledges like this. As you can see, now I'm making the ledges. Let me see if this is right. There you go. So what we're going to do, I think let's make this ledge something like this, and now let's make our ledge stripe to be in here. All right. Now that we have our ledge and we have also the ledge stripe, which is going to make the character to detect that this is supposedly a ledge for the character to catch. So this ledge stripe is very important because let me show you how that works inside the game. So if you have that ledge stripe placed wrong, so let's say for example right over here, and if that ledge stripe is on the way, as you can see, if I press F, as you can see, that ledge stripe is going to, as you can see, the character is going to detect that ledge. It's not showing up right now because I have an option set up in here of the actor hitting the game. So as you can see, the ledge stripe is going to be floating in the air as well, so that we can see it. So as you can see, if the ledge stripe is placed incorrectly, that could cause the character to be just floating in the air. So just be careful when placing the ledge stripes. All right, so the next thing you're going to do now is just go to collision settings. And here in collision presets, you're going to choose custom. And here for the object type, you're going to select ledge. Here we're going to ignore everything. We're just going to block the visibility for the traces so that the traces can detect this object in the code. What else in here? For the collision enabled, you're going to choose query only so that only traces can detect it, but we're not going to have physics collision so that it doesn't block the player's movement if the character, if the ledge is on the way of the character. All right, so I think that's pretty much all you got to do here inside the code. I'm not going to do the whole code from scratch. I'm just going to explain you what I've just done right now. I've just explained you how to move the animations, create the project, basically install the animations to the project, prepare the animations so that we can use these animations inside the code, and prepare the ledge stripes, prepare the kind of level design prototype that we have in here, prepare the collision settings for the ledge stripes so that the character can be able to detect those ledge stripes and be able to attach on the ledge. And I'm going to follow up with the code right now because I think there's nothing else very much explaining here. We're going to talk about later about the tags. We're going to talk about the tags later. So the way the tags works in here, the way the tags work, the way the character can basically rotate and face the ledge is oriented by adding the tags. So here, if you click on the ledge stripe and go to actor, here you're going to go to advanced and tags. So here you can click on in here, you can choose a tag. So let's say 0. So if the character is if the character attaches to this ledge stripe, the character is going to be facing this way, which means the character is going to move to the correct position, right? So if you change the tag to be 90, then the character is going to face this way because the tag of the ledge stripe is going to be 90. So you can basically choose which location the character can be, which rotation the character can face at when he attaches on the ledge. So let's say you made a mistake. You placed the tag to be 90 in here instead of 0. So the character is going to be facing, I believe, to the right. So as you can see, when we attach to that ledge, the character is going to be facing to the right. So this is going to be a tutorial for just explaining what I've done in the code. It's not going to be a tutorial where I do everything from scratch. And the reason why is because I think it's going to be a lot better for me to explain things and explain what I've done other than just do everything from scratch. I think it's going to be a lot less tiring for me to explain everything from scratch. So in this tutorial, it's just going to be an explanation tutorial, a video of what I've done and how I've done things. And it's going to be a lot faster, and I think it's going to be much more didactic for you guys to learn. It's going to be much better for you guys to learn. So I already have the project available that is also available for standard members. As you can see, this is the project that you're seeing. I think at that distance it works good. All right, so the first thing you're going to do, I'm just going to explain you this code part here, I think first, or maybe we could go to the ledge system graph. Yeah, I guess we can go for the attachment part first, and then we can go to the ledge movement navigation later. I think this is the easier part to go through and explain everything, how everything works. All right, so here when you press F, as you can see, we have a Boolean that tells pretty much if the character can attach to the ledge or not. Now you can make this Boolean, of course, because without F, as you can see, nothing happens. Let me just try to debug this first. So you're going to create a new Boolean called can attach to ledge. And the default value is going to always be true because the character is always going to be able to attach to the ledge, unless you have like maybe you're swimming, so the character so this variable could just be set to be off if the character is swimming or doing any other action that won't make the character to be available to attach to the ledge. So you can always add this boolean in here. So you're going to create a new variable, call it to be can attach to ledge. So if the character can attach to the ledge, then we're going to choose and pretty much check if the character is already climbing on the ledge. By default, this variable is going to be false. So if the character is not already climbing on the ledge, as you can see, it's going to go to false, and then we're going to run the attach code. Now, if the character is already on the ledge, we're going to run the detach code so that we can use the F key just both for attaching the character and detaching the character from the ledge. So once you attach the character on the ledge, we can just press the same key, which is F, to detach the character from the ledge. We're going to have another Boolean for managing inputs, so that if that Boolean is true, we can basically run other codes for inputs, such as climbing, jumping, crouching, all those other things. And that pretty much prevents other bugs. So I think it's good to have that can process input variable in here. So that it pretty much checks if the player can move, can do actions with the input, such as crouch, jump, attach to ledge, blah, blah, blah. So it pretty much verifies if the player is allowed to input any key. All right, so if the character can process, can receive any inputs from the player, we're going to go for the next step, which is spawning the hang trace attachment. So if you don't have that, as you can see, if you press F, we just run the capsule trace, of course, but nothing happens later. So it pretty much performs a trace to detect a valid ledge in front of the character. So if a ledge is hit, we store the hit result for further attachment logic. So as you can see, we just run a capsule trace for objects. You can easily get it from this capsule trace for objects. Now we have two, which is multi-capsule trace for objects and capsule trace. So just be sure to select the first one. The radius here is going to be 37. This is the value that I found the best. I think it's pretty much almost the same as the capsule of the character, almost the same radius. The half height is going to be 74. But of course, you can always change the radius and the height of the capsule to better, fit your needs. Maybe you have like a bigger character with a bigger capsule. You can always change. Or maybe if you have like a smaller character, you can always change the radius and the half height, whatever makes sense for you. So yeah, these are the values that I found the best. There's not much things to talk about this. The start and end positions are pretty important because it pretty much decides where the trace should start and where it should end. It works like a line trace, but as you can see, it spawns two capsule traces, but it's just one. It's because it's spawning I'm not sure how to explain this, but the capsule trace, it has a start point and an end point. And then you can pretty much define what are these points where the capsule is going to start and where it's going to end. You can also edit how much forward the capsule is going to be from the character. Now, skipping this one, we can go to the object types in here. So this is very important because it pretty much tells you which kind of object you want to detect. So if you just specify the ledge to be in here, it's only the capsule trace is only going to detect the ledge and not other objects. So if you want to detect, like for example, the word static, the trace is only going to detect the word static object channels. So as you can see, it's going to detect this one, the word static objects. So as I want the capsule to only detect the ledge type of object in here, you just got to make sure that the ledge is the ledge collision settings is set to be ledge, so for the object type, so the capsule can only detect that object type, such as ledge. So all you got to do is go from here, object types, and make array, and click on ledge. So you can select the the ledge for the capsule to detect. Now in here for the draw debug type, as we're only running it once, we're not running in the event tick, we're going to choose for duration. So the capsule disappears after 3 seconds, but you can also change it to disappear after 10 seconds. So as you can see, if you click on F, it's going to disappear after 10 seconds. You can count it. And you can also choose the trace color, the trace hit color. If the trace hits an object, as you can see, it turns blue in this case. But you can choose whatever color you want. So I usually do for duration for this one. And the seconds is 3 seconds. And ignore itself, ignore the character, because the capsule cannot identify, it's not going to be running for, I don't want the capsule to identify, to trace against myself. So now here for the calculation, we basically do a calculation to position where the trace should be at. So all I'm doing here is just specifically telling the engine that I want the capsule to be a little bit forward based from my location, from the location of the character. And I want the end position to be a little bit backwards, or you can choose vice versa. So if I choose here for the start location to be maybe, so the forward offset is here, like 16. If you choose it to be 50, as you can see, the capsule is going to be too much forward. And you can also change these values to see which one works the best. The start also has a offset that puts a little bit up. We can also change this value here. So if you put like 50, as you can see, if you press F, as you can see, it's going to be a little bit up. And that's pretty much it. Now here on the out hit result is the structure that pretty much tells everything, like the location of where the capsule has hit the object, the impact point, which is I think almost the same thing, the impact thermal, what actor was being hit. If it's a component, it pretty much tells you the component information. If it was a skeletal mesh that was hit, it pretty much tells you the bone name and the distance related to the character and so forth. So we're going to just promote it to a variable so that we can use it later. And we're going to also use this information later to calculate the angle that the character should face at, which location the character should be attached to. And so here in the return value, you pretty much tell if the capsule trace has hit something, it tells you if it has hit. So if the capsule trace hits something, this Boolean variable here is going to be true. It's going to return true. If it didn't hit something, it's going to return false. And then I'm going to pass this information to be read in here. So we're going to check if the trace did hit a ledge. So if it didn't hit a ledge, we're going to notify the character that did hit trace first attachment should be false. So if the trace has hit something, we're going to go to the next phase, which is just going to be updating some values, as you can see right over here. So this is just going to be updating some values. So after this, if the trace has hit something, it has hit the ledge, we can just prepare the character's movement, and we can just basically update some values. So in here, we're going to update some values, some states. So as you can see, we can disable the can attach to ledge so that the character is not going to be able to attach to the ledge anymore, as he is already attaching it. So can process input is going to be false. Now we're here going to prepare the character movement. We're going to set the character movement mode to be flying. And at the beginning, when I was learning Unreal, I was wondering why we would set the character to be flying to play a animation montage. So the reason why is because the character is going to be in the air. So we need to basically set up the settings, the necessary settings for the character to be in the air. It's because if you would set to be, for example, walking, and the character wouldn't behave appropriately. So for example, here, if you would attach to the ledge, as you can see, if I try to make the character to go into one direction, the character would not just move, would just not move, right? Yeah, it's telling that there is no tags in here. Let me just try this other one. That's why we're having some bugs. So as you can see, I try to move, but it doesn't happen. So the only movement mode that you can set so that it can work is the flying mode. If you set it to falling, it's not going to work. As you can see, the character is going to fall into the ground. So the best option is going to be the flying one. Here, I like to make the stop movement immediately to be in here so that the character does not slide off immediately when we attach to the ledge, and it makes the movement more precise. So the max fly speed is also prevents the character from sliding off the ledge. We set the mesh and the capsule component of the character to be no collision, because sometimes the character might not have a especially when you do corners, the character might require a little bit for the capsule to enter, overlap the box, or if you have any other object that is going to be interfering, that could cause a little bit of bugs, so the character wouldn't be 100%. It wouldn't be that much precise for the character to calculate where he needs to be at. So setting the mesh and the capsule component of the character to no collision is going to prevent bugs that could prevent the character from doing its action of moving from one ledge to the other. Here I like to set the character movement, a rotation movement, to be facing, but I think it doesn't make a difference if you turn it to be true or off in here. So here we update some values, and here we play the ledge catch animation. Now in this part, you need to have the retargeted animation already. Now, if you don't know how to retarget the animation when you first download the pack, I'm gonna also make a separate video for you guys to watch it. So this is the animation. As you can see, it's leap. It's called leap entry to climb hang idle montage. And here, for playing the montage, we need to specify a slot name. that is called ledge slot. So when you first create the montage, it's going to be assigned to a default slot. And the reason why we have different slots is because we can choose which specific slot in the animation blueprint you want to execute. So if I were just to select the default slot, the character wouldn't be able to play that montage. As you can see, it's actually playing that montage, but it's not being executed it's not being shown in the front end. But if I select the ledge slot, the character is going to be able to execute that montage perfectly. And that comes from here. If you want to make a new ledge slot, which you have to do, we're going to go to the window. If you don't have this tab in here called Animation Slot Manager, we're going to go to Window and click here on the Animation Slot Manager. So here we're going to add a new slot. Let's say, I don't know, upper body. So here you can choose now the upper body slot. So all you gotta do is just choose to have the ledge slot in here and select it and assign it through here. So after you've done that, you're going to prepare the slots like this. I think this one is not really needed, the full body slot. So after the pose history, you're going to save a new cached pose. You're going to name it to be such as base locomotion, or maybe base motion matching. And then here we're going to create a new state machine. So ledge state machine. I think this one I'm gonna have to do it from scratch, so it's better to understand. So in here we're going to, inside that state machine, we're going to use the cache called base motion matching. So we're going to cut this, and then from here, from the entry, we're going to add a new state called base motion matching. And then here you're going to just paste the use cached pose, or you can just retrieve it from here. So use cached pose, base motion matching. It's the same thing. All right, after you've done that, you're going to plug in a new state from the base and add a new state. And here you're going to choose ledge, I don't know, ledge locomotion, doesn't matter, ledge movement, ledge state. And here for the transition from going to base motion matching to ledge state, we're going to get the property axis. We're going to go to the sandbox character. Where is it? Here. We're going to go to the sandbox character, and we're going to search for already climbing ledge. So we're going to connect it to here. I'm going to copy this boolean so that I can add in here as well. I'm also going to have the blend poses by boo, which is just going to be able to serve it to be just switch. So if the character is in the climbing state, this one should be going to true. And if it's not, we should use the base locomotion, base motion matching. Now the true blend time and false blend time should remain to be 0.1. I'm going to explain these values later. And before the ledge state machine, we're going to get the slot, default slot, so that we can change it here to ledge slot. So that's what's going to allow the character to play the ledge slot animation montages. After that, you can just click here on execute the output pose after that. So now the character is running back the default pose of the motion matching. And as you can see, if the character is not climbing the ledge, it's going to be false. So it's going to execute the base motion matching, which is this one. So if you press on play, as you can see, well, now the character is going to be able to use the normal motion matching. And if he attaches to the ledge, as you can see, the animation is going to be playing. So as you can see right now, the character is on the A pose. And the reason why is because when you execute a state that doesn't have any animation, as you can see, the character plays the animation montage because we're using the ledge slot, the correct ledge slot, which should be set in there. And we're using the correct ledge slot in here. So as soon as this variable is set to be true, we execute this ledge state machine. We execute the ledge slot. We allow the character to play animations that are animation montages that have the slot set to be ledge slot as it is in this one right here. And then we can play the animation. So if you play, as you can see, but now here on the state machine, on the ledge state, as you can see, we don't have any animation. So that's why the character is on the A pose. So if you don't have any animation here, the character is going to be on the A pose. Now all you gotta do is just going to go and search for the hang idle. I think it's this one. It doesn't need to be a animation montage. Even if you try to get an animation montage, you cannot be. It has to be an animation sequence player. Animation sequence. So all you gotta do now is just connect into here. If you compile, save, and press play, now that animation, that ledge idle animation is going to be playing. But of course, this animation here is a loop animation. It's an animation that keeps looping because it's an idle animation. So if you press play and then just, as you can see now, the loop animation is going to be going. And if you don't, as you can see, the loop animation just stopped. The animation just stopped playing. And the reason why is because we haven't specified here to loop the animation. So we can just have the option to be true so that the animation can play and loop and keep looping. Yeah, so that animation should loop because that's an idle animation. And I think that's all you gotta do in here. Of course, you can change the play rate and how fast the loop animation plays. You can change it to be like 2. So the character is going to be very... It's going to look funny. You can change some settings in here if you want to. You can change the start position, blah, blah, blah. But that's pretty much all you gotta do in here. I've decided to make this part from scratch so that you can understand how it works. Because some nodes that you can get, it requires a specific way to get the informations. Yeah, that's pretty much it. I'm just going to delete this part because I don't need it. So that's how you should set up the code part in the animation blueprint. That's pretty much all you need to do in the animation blueprint. We don't need to touch it afterwards. After you've done this, you don't even need to touch this part of the code in here. You can just let it intact. Now here we play the ledge sketch animation. Of course, you're going to go through here and go like play montage, the first one. And then here you're going to select the skeletal mesh. You're going to just drag and drop it into here. And then here you're going to select the montage to play. So just remember, we gotta get the entry leap, entry hang idle. So just select the animation montage to play in here. And that's pretty much all you gotta do. And we set this variable to be set to be true, set to be false twice, I think twice. So we don't need this variable here. Yeah, anyways, we don't need that variable in there. It's not really necessary. All right, so here we disable this modes, not glitch the ledge movement. This is for the gas project. Now, if you're running the third-person template project, you don't really need to do this, but of course you're gonna have to disable some settings. So here, what I want to do is just disable the wants to strafe, and disable the strafe mode if the character is on the strafe mode, and disable the aiming mode. So if you don't run this, let's see what happens. So as you can see, the character is going to be strafing, and we can press to strafe, as you can see. So if you compile, save, and attach the ledge, as you can see, the character is not going to be strafing. So that's why it is for. That's what this is for. Now for the next thing we're going to check is if the character did hit the trace. I think this is not really needed because we already check it here. But yeah, this is not really needed, but I like to have a secondary prevention. Here we save the initial ledge angle when first attaching to a ledge. Now that's very important because you want to know which angle the character is going to attach. So for example here, if you take a look at the tags, if you go here to tag, and as you can see here is 0. Now if this tag, let me just get this slide to be in here. Yeah, let's just get this one. So if the first ledge, yeah, we can do it with this one right here. Let's just put this ledge away just to test. So if the tag in here on the ledge is like set to be 90, for example, instead of 0, then the character is going to rotate to that direction, the 90-degree angle. So if it is set to be negative 90 degrees, and if we attach it to that ledge, as you can see, the character is going to face that direction. Now, of course, there is a way to set the tags automatically through the code, but I'm not sure if you guys really need it. So maybe 180. So that's pretty much going to decide where the character should face at. Of course, there's a way to make this automatically, but it's all going to depend on you guys if you guys want it. If you guys really want it, I can make a tutorial for this, for making it to be automatically. There is a way to do that. So yeah, you should just place the number, the rotation that the character should face at in the tag, so that the character can perfectly align itself and face the right direction. So let's say you make a ledge for this side right here, a 90-degree. So as you can see, if you just use the same tag, why I cannot? Oh, there we go. If I use the same tag, the character is not going to be correct on the ledge. But if I use negative 90, as you can see now, the character is correct. It's correctly attached on the ledge. So if you just keep that part from the code, and then you try to attach on the ledge, the character is not going to be able to read like which orientation he should be facing at. So in here on this code, we save the initial ledge angle when first attaching to a ledge. So here we create a float that we can store which rotation the character should face at on the ledge. And in the code, in the collapsed graph, we get the ledge angle by getting the hang trace. So that's why I told you to promote the result of the capsule trace, the hit structure result, so that we can use it later. So we're going to use it for getting the ledge angle based from the tag that we assigned to it. So we get the hang trace. So it pretty much saves the detected ledge angle when the first time that the character attaches, used for the later calculations and consistent ledge alignment. So if you don't have this code in here, the character won't know which rotation he should face at. Now, I've already tried different methods like getting the rotation of where the ledge is facing, but that didn't really worked well. So I opt by using this by tags because I have more consistent results without having any bugs. So it's 100% sure that if you use the ledge stripes and the tags correctly, you don't have any bugs basically. So here you get the hang trace, we get the break hit results that we can access what's in the structure. Now, of course, you can also do this. You can get the hang trace and click here on split structure so that you can access all the content into that from that structure. So as you can see, you have a lot of options to get which information you want to get. You can just get it from here. Of course, you can do it this way, or you can just break the hit result. It doesn't really matter. But I like I like to use the break hit result because it's much more simpler. It gets to be more organized because you can collapse the thing in here. All right, so we're going to get the tags out of the hit actor. We're going to get the reference. So there is 2 gets, one for getting a copy and getting a reference. I think both works. I'm not sure about the difference, but I think get a copy works very good. So here we're going to use 2 nodes, one for converting into a float. So actually it's to a string. So here you're going to use toString and then toFloat, string to float, and then finally we're going to make a literal float. Actually, we don't need to make a literal float anyway, so you can just go to outputs and there you go. So you're going to go to the ledge angle, you're going to execute it so that the character can know which direction he should face at. And there you go. All right, so once the character is rotated to face the ledge, we calculate both the current and target positions to correctly align the character onto the ledge. So these calculations are for calculating here with the timeline which location and target location the character should be set to be at. And there you go. I think we also set this, so set actor rotation. I think I'm just missing one calculation here. So without this important code, yeah, I'm going to show you before and after, and I'm not going to say anything. Just watch. Without this code, the character, if you go to this angle, the character goes through the block. Now with this code, so it pretty much prevents the orientation bugs. So what happens here is that when we execute a location correction, we firstly need to set the actor's rotation to where it should be so that we can have a precision calculation of placing the location of the actor. So as you can see, the character is aiming this way, but he wants to attach on this ledge. So if we just set the rotation of the character right away to where the character needs to be at, we just need to now move the character to its position. So we just need to move the character forward. So in the code, we have the calculation for moving the character forward. So let's say, hey, this is get the current actor forward. I don't know, location. Get the current location, the current forward position here. So we have the code for calculating, for basically moving the character forward. And then we also have the calculation for moving the character's location to the left. So we firstly run the calculation for the character to go for the left. So we run the calculation for going 90 degrees. So after the character has gone to that direction, we calculate the character to go forward. But if the so that works. So if the character, basically the character is going to go to the left first, and then he's going to move forward. But what happens if the character runs the location first and then the rotation? So what's going to happen is that the character is going to move forward. So instead of going here, the character is going to go forward, and then he's going to go left. So instead of going to the ledge, he's going to go right to the right, the other side. He's going to go not to the ledge direction, to the ledge destination. He's going to go to the right. So that's very important to know. I literally spent a lot of time trying to figure it out, but then I finally found a solution. So here we're going to calculate the current location and the target location so that we can know which how we should move the character from point A to point B. So here, for making the calculation for the target location on the ledge, basically that's the calculation for moving the character. We have a specific offset of how much the character should be placed forward and backwards. So here on this value called init ledge forward offset, we can change the forward offset so that the character can be too much forward or backwards, depending on like which character scale you have. What's the size? Maybe the size of the hands also matter. So here you can change the forward offset, and here you can change the vertical offset. How much down or up you want your character to be on the ledge. So let's change this value here. Let's change this value here first, so that I can understand how it works. So here right now is 38. Let's put it to be 90, so you can see the difference. So when you first attach on the ledge, as you can see, the character is going to be too much backwards. If you put it to be just 1 or 2, as you can see, the character is going to be too much in the ledge. So that's perfectly... That's going to be the value that I can add at the forward offset, and here's the vertical offset. Right now it's negative 18. If you change it to be like 60, the character is going to be too much down. Anyways, now you know. Now you can change these values to see which one works the best. So only use these calculations. Only use this calculation if the character is already facing the ledge. Otherwise, it may cause an incorrect forward offset or similar bugs when snapping the character to the target location. All right. So here we get the hang trace. So we get the impact point, which is where the trace is. We get the forward vector to calculate how much forward the character should be at. Here we use a ABS to basically convert. If this is a negative value, we should convert it to be positive. I'm not sure why I've done this code. I don't remember exactly why I've done it. So here we update some timelines. Here it basically pretty much resets the timeline state, location, and rotation to prevent desynchronization or repeated execution bugs. Because when you're running a timeline for the first time, you want to know when the timeline has finished or when it has started. So this is just a way of making the code to pretty much tell the code that the timeline has just started. And here we play from start, the location and rotation timelines. So here we have the timelines. For making the timelines, it's pretty much simple. I'm gonna do one from scratch so that you can understand how you can do one. So here you can click on add and then timeline. And then here you can choose what's the name of the timeline that you should be set to, or let's say location, timeline, character, for example. So you're going to double click on that timeline. You're going to add a track, add a new track, add a flow track. And then here you can choose a track name. I don't know, alpha. The length is like how much seconds you want the character to attach on the ledge. Like how fast you want the character to attach on the ledge. I like to choose a value between like 20 milliseconds or 30 milliseconds. I think I'm gonna do 22 milliseconds because that's the value I've chosen to be before. Now in here, you're gonna have to make a linear curve. So how can you do that? So here you can right click, you can add a key through here on this option, or you can just hold shift, left shift and left mouse button, left mouse click to add a new point. So you need to add 2 points to make a linear curve. So you're going to do once more. And then here for the first key, for the time, we're going to choose it to be 0, and the value is going to be 0 because they're just starting out. And then in here, the time is going to be 22 milliseconds, and the value is always going to be 1. So you can press F to just zoom in here, and as you can see, if you click on this key, you can see the time and the value. And then here, you can see that the time is 22 milliseconds and the value is 1. We use the value 1 because we use a specific function that requires a value from 0 to 1, which is this one over here. Let me show you. So this is the function. The function name is going to be called Lerp vector. And then it lerps one value to the other. So it lerps from the point A to the point B, and it requires the alpha value. So if the value is 0, then it's going to be A. So that if the value is 1, then the value is going to be B. So if the value is like if the value is like 0.5, now this Lerp vector here function is going to basically calculate the medium distance between A and B. And if this value is set at runtime from slowly going from 0 to 1, then the character is going to go slowly from point A to point B, right? So you pretty much define how fast the character should go from one point to the other. So let me just give an example here. Let's go to the event graph. And here on the event tick, I put this Lerp vector. At the beginning, when I was learning how to lerp values was very difficult because I found very little tutorials that could explain it well. I think one good way to explain how this lerp vector works is by making calculations like this, for example. So here on the event tick, which if you print a string and press play, as you can see, it's going to print a lot of strings because it's executing at the runtime. If you just put this value, yeah, let me just reset everything. Alpha 0, B0, A0. So just click on play. So as you can see, it's all 0. But now if the A is, let's say if the A is 0 and the B is 10, and press on play. Now, as you can see, the X, Y, Z are zeroed out because the alpha is 0. But if the alpha is 1, then we're going to get 0, 0, and then 10. So watch. So as you can see, it's 10 now, because we just moved from 0, which was the state of being here. Yeah, I'm not sure how to explain this well, but it just works. So if you set the alpha 1, it gets the value of B. If you set the alpha 0, it gets the value of A, which is 0. If you get the value the halfway between them, like 0.5, for example, you get 5, right? So if you use that to translate the character from going to point A to point B, you get the medium result. Yeah, so that's pretty much it. If you want, you can split the structure, and as you're only working with the Z value, you can just print the string, print the value of Z, and then you get 5. So if you set it to be 100 in here, you're going to get 50. Let's say if the alpha value is like 0.2, so it's going to get 20. right? All right, so what we're gonna do here is just basically simple. We're going to set the actor location, and we're going to get the Lerp vector. So here, as we've calculated the current location, we're going to get the current location variable, and we're going to also get the target location. As the current location is the starting point, we connect it to A, because A is always the starting point, and the B is the end point, is the target point where the character should be positioned at, which is the target location. So we connect it to there, and then we connect into the return value is going to be connected to the new location, which is going to be set through the set actor location function. So all you got to do now is just play from start. The way I got this variable was just by getting the name of the timeline. So you can get the name and then get the name of the timeline. So get location timeline character. As you can see, you can just drag out of this and get the play from start. As you can see. And then there you go. So you can play. And then get the character to attach on the ledge. Of course, you need to set other values. But that's essentially it. Actually, you don't even need the rotation timeline. The rotation timeline, because you already rotate the character through here. So I think it's not really needed. So all you gotta do now is just reset the value. So can attach to ledge back to, we set this to be finished so that we can move the character. We can delete this. Delete all this. I don't need this. There you go. So press on play. What's going on? Oh yeah. As that timeline was also referenced there, I'm gonna have to change the references. So just get the timeline name, stop, and then connect it to here. So when we detach the character, we need to make sure that we stop the timeline, because if we detach the character without stopping the timeline, if the timeline is still running, we're gonna have some issues. We're gonna have some glitches. That the character is just going to be fluctuating the air. All right, so as you can see, it's working. Now, of course, if you change the timing here, like how long it takes for the character to attach and position itself on the ledge, let's say 2 seconds. And then if you change the endpoint of the timeline to be 2 seconds as well, as you can see, if you press on play and then attach on the ledge, so as you can see, it's gonna take 2 seconds for the character to attach on the ledge. As you can see, it takes 2 seconds. All right, so that way you can understand how timeline works, how timelines work, and how the Lerp vector works. Yeah, let me just change those values back to 22 milliseconds, or maybe 25. If you don't, after the timeline finishes, we need to set these values back to true so that we can make sure that the character can attach to the ledge and can process the input. So if you don't do that, as you can see, if I keep pressing F, the character is not going to be able to detach. So I need to do this. So when the timeline is run, it's going to do its job. It's going to move the character to its position and blah, blah, blah. All right, so this part is done. We could explain everything, how the attachment code works. Now we're going to go for the detachment part. I think that's going to be a lot easier to understand. So for the detachment part, we check if the character is already climbing on the ledge, which is going to be true if the character is already climbing. There we go. Let me see. So when you press F, as you can see, this variable is going to be true if the character is already climbing. And then this one is going to stop the active ledge transition, timelines, location, and rotation. Actually, this one is not only this is only location now because we deleted the other one to prevent one unwanted movement after the player detaches. So this is just going to make sure that the timeline stops running if in case it's running. And in here we run a montage stop. This is good for specifying. Yeah, I'm not sure why that happened. Let me see. Oh yeah, I think the tag name was 0. Actually, we don't have tags in here, so let's set it to be 0. So this one is 0, 0, and this one is 0. That's why I had that bug, I think. I just got an error here. Attempted to access index 0 from array of length 0, but then it didn't have a tag, but now it does. So this is how fast the animation goes from one pose to the other, because we have a blend time that we can specify to give it so that the character can smoothly detach on the ledge to go from one pose to another. So you have a specific blend time that makes the character to go from one pose to the other. So for example, right here, I'm gonna do it slow motion. If you press F, as you can see, that takes that was supposed to take like 25 milliseconds, but I think that's less. And the reason why I think that's less, because the blend poses by Boo also decides how fast the character should go from one pose to the other. So as you can see, if you debug this and go to, I'll just expand this a little bit. So when you go from here, as you can see, I'm going to do it slow motion now. Pay attention to the blend poses by Boo, how it's going to change it. So when I go F, as you can see, the blend poses by Boo also decides how fast the character should go from one pose to the other. So we have the true pose and the false pose. So it decides pretty much how long that should take. Now, I think I should set the false blend time to be .25. I think that's going to be a lot smoother. The character is going to detach a lot smoother on the ledge. So when you click on, as you can see now, that's going to take 25 milliseconds. So as you can see, yeah, I think that's a lot smoother now. But the montage stop also going to help, but this is going to decide more how fast the character should blend. Alright, so when we stop the montage from playing, if we have any montage playing, we prepare the character movement for detaching, so we can set it to falling. I usually don't set to walking because only if the character is already on the ground, as you can see. It works the same, but I think falling works best. We have better transitions. We reset the collision enabled back to capsule and mesh. For the capsule and mesh, we set the ledge navigation timeline finished, and we set all those variables to back to where they should be. So that's the detach code. It's a lot simpler. All right, so now that we've learned how to attach the character, yeah, I'm not sure why that's going on. Attach location. Maybe it's because of the code I've deleted in here. Absolute float. I'm not sure. Yeah, I think the rotation timeline is also needed in this case. Rotation timeline. So I'm just going to do it real quick. Ledge. Now I don't remember how I've done it. I'm going to get the current, get ledge angle. And here you're going to get the Lerp rotation, Lerp rotator. So to make the rotation timeline is very simple. You're just going to duplicate from the timeline that we just made. We're going to set the active rotation. We're going to get the current ledge angle just for the Z because we're just going to move the character on the Z axis. We're going to get the active rotation, but I think this one should be not on this because we're moving the current character's rotation from A to B. So the A should always be the initial location where of rotation of where you should want an actor to move. And the B should always be the target destination. So we're going to get the current ledge angle, which is, we're just basically reading which location the character should be facing at. And I think that should be done. That's going to be it. Now I'm going to press on play. It's going to also work. I think that's a lot more safer to also execute the timeline because sometimes the character should... that's going to just basically force the character a little bit to move and face the ledge. That's going to force him to face in case anything happens. Now we're going to go into moving the character on the ledges. Now that I've finished the attachment on the ledge, attachment and detachment, we're going to work on the ledge navigation system, which is this one. So you can press left, right to move the character. So you can press left or right to move the character on the ledge. So let's do that right now. Oh yeah, and also if you get your gamepad controller, you can also move the character. So let me just get mine in here. You can also move the character. So as you can see, I'm moving with my gamepad. So you can move pretty much the character in any direction. Let me show you a project that this is the premium one. If you get the character, you can also see how it works. Hopefully the stream is not going to lag a lot. So this is the complete system, complete and advanced system that we have. So you can climb on top, climb down, drop, climb up. You can also do corners. You can also do inner corners. Without any bugs. You can also do freehang. You can also climb on top. And this is not done yet because you also have some bugs, as you can see. The character snaps sometimes. Freehang. You also have the leap 180. Now here for the movement input, you're going to promote the action value. So this action value pretty much tells you which direction the player is moving which direction the player wants to move the character. So if you press W, essentially you're telling the code to move forward. If you're pressing S, then you want the character to move backwards, something like this. But of course, that's going to depend on the perspective and if the character is strafing or not. So essentially, that's what it does. So we have this vector, which is a 2D. So you pretty much, for the action value, if you break in here, the vector. So I think the X should tell you, if the X is +1, it should tell that you're pressing W to move forward. If it's -1, then it tells that we want to move backwards or to the left. So if the number is negative, it should be the player wants to move either left or backwards. If the number is positive, then the player wants to move forward or to the right. That's essentially it. So we're going to promote it to a variable because we're going to be using it later. We plug in the cancelled and completed actions as well because we want to know if the player has released one of the keys as well. Here we create a macro called action values management macro. And this one, we have 2 execution inputs in here. So it's called triggered and cancelled or completed. So we treat each case differently. So here for the inputs of this macro, you can of course create a macro by clicking here on macro, add a new one. Triggered. So here you can add a new input if you want to and choose execution, rename it. So we're going to block the inputs if false. Here we validate the values. This blueprint checks if the player can move. If not, it forces movement inputs to 0. If yes, it reads the real inputs, stores them, then rechecks them. There we go. So here it promotes it to a variable. So maybe here you can just take a screenshot because I'm not sure how I've done this. I just made it to work. I don't really remember what I've done to and why I've done this, but essentially we're just promoting values and we're just resetting them to 0 if the player is not pressing any key. And here for the X, at least we're just routing up some values so that we can use it for the trace later. So then we connect it to outputs, and then we move to the next validation check, which is the already to check if the character is already climbing on the ledge, because if the character is not climbing on the ledge, then we were going to run the default movement, which is this one right here. So if the player is not climbing on the ledge, we're going to use this default. So if the player is going to be climbing on the ledge, if the player is climbing on the ledge, and press F, as you can see, and try to move, as you can see, now we run the ledge detection. And if the ledge detection detects a ledge, then we're going to go to the next step, which is the ledge climb movement. So as you can see, if you go up, it detects. So let me just explain you real quick how I've done this ledge trace detection function. So here we perform a trace in the direction the player is aiming. The 2D navigation up, down, left, right. So here we run a capsule trace for objects, which is the capsule that you see right over there. So here the radius is 30, the half height is 40. You can pretty much change those values later. Now, what I want to do is just place that, what I think is happening here, the trace is a little bit up. I think I wanted to place a little bit down. Maybe the Z offset, you can change it here. So as you can see, the capsule is too much up when you aim to the left. So yeah, this is going to be a mess to explain, but essentially what it's doing here is basically reading from the player's input. So based on where the player aims, we can place the ledge on that location. So if the player aims to the left, we position the trace to the left. If the player is aiming to the left and up, we add up that value vertically. Yeah, this is it requires a little, to explain this, it requires a big brain to explain. So essentially that's the code for doing it. Here we have the start location and end location. Of course, we make the ledge to be detected for the object type. And here we control the up vector. And this is also work in progress, so I think it's not really worth it to explain everything right now because it's going to be changed. Now, I think a better way to do this would be using a multi-capsule trace for objects and then detect every single... Yeah, but I think that's not... Yeah, I'm not sure if I should do this. I think there is a lot of ways you can do things. And sometimes doing the basic is what works instead of just complicating things and not making it work. I've gone through that a lot. Now, if the capsule trace hits an object, then we go to branch, we get to true, and then we set the ledge hit detector to true. And then we promoted the values of the hit structure of the ledge. So we basically get those values later. We retrieve it from the... We just save those values to be read later in the code. And then we just plug the ledge hit detector to the return node so that we can read it after. Condition. And then we go to the ledge climb movement. All right, so basically what's happening here, if I just unplug that, yeah, it's not gonna happen anything. So when we move up, we detect. The ledge trace detection gets to be in here, detect. so that we can move to the next step. So the next step, it's a lot more than you think. So here you check firstly if the character is already climbing on the ledge, again, to prevent bugs. As you can see, when I click here to move in any ledge, as you can see, it goes to here. It checks if the ledge navigation timeline has finished, and then only continue if player is pressing any key. I'm not sure why I set this value to be 1. Save custom inputs value if it has an input. I'm not sure if we change it to 0, I'm not sure what happens. Yeah, I'm not sure. Let me just set it to be 1. Let it to be set to 1 because I'm not sure. Maybe this is a mistake by me. Anyways, so we save and update inputs. If we don't do this and press play, nothing happens, I think. I think it's good to have it. So check if the ledge got hit. And then here we gather and process all ledge related data, impact point, target transform, angle, reach distance for use in movement, and transition calculations. So after the ledge is detected, we run a series of checks. So firstly, we check for the target data. Essentially, we're going to check what is the direction that the character should face on the ledge, where exactly the sphere trace has hit on the ledge, what is the tag that is attached, that is assigned on the ledge, what else? The angle difference between the character and the ledge. And then here we determine the ledge direction and the ledge montage selector by enumeration, and then we have all this. So let's go first with the process ledge target data. So first of all, we get the current location of where the character is, which is very important as well. So here define the character's center point, so it can serve as the base for calculation and for comparisons with subsequent target points. So the reason why I'm doing this is because let's suppose the character is right over here, and then when you get the actor, when you get this node called actor location, we essentially get the actor's location point. But as the character is on the ledge, let's say the ledge is right over here. So let's say his hands are like over here, and then let's say the ledge is right over here, right? So we need to decide where we should consider the center point of the character, because if you only get the actor location, it's going to get the pelvis location. So imagine you get the actor's location center, you get this node called get actor location, and then now you need to go to the next ledge, which is this one right here. Now, and then there is this one, and then there is this one, let's suppose. Now, if you just get the actor location, if you go to this ledge right here, and then let's say the ledge trace detected this point, as you can see, right over here, to the same point. Now, if we would define the center point to be right over here, right in the neck, as you can see, the angle is much more different. Now, the angle, instead of being like, I don't know, 30 degrees to the right, it's now 20 degrees to the right. So that pretty much tells the difference, that pretty much tells which exact animation you should be playing. Because I think it makes more sense to just define the center of where the character location is right in the neck, so that we can have a better precision choice of where the character should be moving at. Now, maybe that doesn't make sense, but I think it makes sense for me while I was testing new animations. And I found out that the best calculation would be this one, calculating from the neck and a little bit forward, because if you take a look, if the character if you take a look at the right side of the character, when the character is on the ledge, like right over here with his hands, if we just get the actor's location, we would get the pelvis location. So the character, the center point would be right over here, and the ledge would be right over here. So we have a forward offset as well. Instead of just, if you just place the center, if you consider the center point to be right where his hands are, regarding the forward offset, if you just get the same forward offset as where his hands are, we can have a better idea and better calculation of placing the character where he should be. I think that makes sense. So that's pretty much what I'm doing right now. So here we calculate the ledge target end, and then here we have the dynamic ledge attachment, impact point, and then this goes to pretty much saves the location of where the capsule has detected the ledge. Here we have the reach distance, the difference of the distance between the character and the ledge. And then we save that distance. That's going to be later used for deciding which animation we should play, because we have a lot of animations. Here we determine the target ledge angle based on which angle it is that the character is going to be attaching to. There is the code. Here we select the forward offset. So if you want to change this value here as well, you can be free to change. So if you change this value, instead of 38, you could put 90. So when the character attaches to moves on the ledge and then goes to the next ledge, as you can see, changes the forward offset. So just choose the right value that matches up with your character scale. Same thing for the vertical offset. So basically we're just basically choosing a different offset depending on the character scale. So after calculating which location the character should be and which rotation the character should face at, we define the target transform, which gets all those values, both the location and rotation, and save it. Here we define the target angle difference. This is used for corner calculations. All right, so here we calculate the target angle difference. If you change this value, for example, here, when you try to move, as you can see, it doesn't work. So we make the transform actor center location plus actor rotation, find the angle between character center and hit ledge target location, get forward vector to compare. We use Y for X and Z for Y because of the three-dimensional perspective angle. Yeah. So we find the delta between the current and target angle. And then here we choose the current ledge angle for the A and targeted ledge angle for the Z. To calculate the rotation difference and check if the last ledge target angle was the same. But I think this code is not really used, so we just promote to a variable. Before I had a code that would calculate if it was the same. So in here, after calculating the process, after processing the ledge target data, we move on to the next step, which is resolving the final ledge movement direction based on lip checks. corner detection and player input, returning the appropriate enumeration for execution. So here you're going to determine the ledge direction. So here we determine the ledge direction. So this function is responsible for deciding the final ledge movement transition, this direction, based on ledge target data. So here we have this enumeration, and this enumeration, it pretty much decides where the character should go. So you should have that enumeration here. To create one is just go to here, create enumeration, and then you're going to add the enumerator, you're going to add the values. So here for the first value, it's going to be up, right down, down. And here you can choose the not set up one, because there might be cases that the trace does not detect anything. It doesn't really know where to go, where the character should go. So not set up is the way to tell the code that, hey, we haven't detected the direction that the character, we haven't detected a proper direction that the character should go to, so we just set it to be not set up. So here the ledge input parameter pretty much tells you where the direction of the character should go. So when you press on play here, when you go up, as you can see, this is executed and then the function is finished. So when we have the return node in here, that pretty much tells that the code that the function should be finished. So when you go down, as you can see, this one down below here is executed. All right. So here I found these values to be like this. So the X minimum is -0.3. All these values here I found by myself by just testing new stuff. So I just found the right values and what they mean based from this calculation here, from the rotation. So we're basically getting the difference of rotation to calculate which direction we should go based from that. So we create a macro called ledge input parameter, and then we have this code inside. And then if the code is if the X value is between -3 to +3, and the minimum of Y is 0.8 and the max is 1, that means that the character should be going to the up, right? That's a little bit crazy to explain, but that's the way it works. So if those values are in those ranges, then it should go up. Then we have those values that means that the character should go down. And then this is right up. And this is right. This is for going down. This is for going left down. And if it's false, then that means that the character hasn't found a valid direction. So we set the enumeration not set up, and we want untick this option here. So that's pretty much it. Let's go for the next one. So if we determine the valid ledge direction, if we haven't determined, then we set it to be, say something like, I don't know, ledge direction invalid ledge direction, something like this, so that we know if the ledge direction is valid or not. So for the next step, after processing the ledge target data, after determining where the character should go based from the ledge directional values, we go to the next step, which is choosing which montage we should play based on the direction that the character is going, and at which distance, which exact montage based on the distance and direction the character should go. So here we select and configure the appropriate ledge transition montage, animation, play rate, offsets, and timeline. Now inside this coding here, we have just this code, but if you take a look at the advanced what I have prepared for premium members, we have this code over here. So we have this much for calculating, for basically choosing, because of course we also have the inner corner, the outer corner, and we should have much more for deciding where the character should go. I think I could just collapse everything into a data table, a table chooser, or choose a table to basically calculate this better, so that we can basically choose the montage based on some parameters, some values, right? So for now, we just, on this code, as we can only move up, and we're using short distances, and we can only move up, down, left, or right. We only have this part of the code, which is pretty simple to understand. So here we reset this value so that it prevents from the latest animation from playing. So here we have a sequence so that it's easier for us to just end the montage and the function. So then 0, we have a branch, and then it checks for the angle. So this angle right here is the angle that it checks for the angle for this one. So if you have this angle like this, but the reach distance, this one checks for the direction and the reach distance. So when you move like this up, it already detects that the character is moving up. So we go to the up one in here. So it pretty much checks if it's between the reach distance allowed. So as you can see, it is allowed, but in here we also check for the angle, which the left and right angle. So you can also change it here. So let's say -50 or +50. And then if you go to that angle, and then you go to that angle, and then do this, as you can see, the character is going to attach to that angle. But I think it pretty much depends on which animations you have. Maybe you're going to have a specific animation from going to that angle. But anyways, let's just delete this. Now here we selected the montage based on the enumeration value. So here we get of course, we're going to have to create the enumeration. After you create the enumeration, you're going to set the variable type to be montage enumeration. So you're going to select it here, name it, oops. And then in here, we're going to basically select the montage, have the selection node, and then put this right over here. And then in here, we're going to select which animation you want to play based on the direction that you want to go. So here, if the character is going up, we're going to select the animation of going up, which is this one. And remember that we have to set the group to be large slot so that we can have a better, so that the animation can be executed in the backend, in the animation blueprint. That's all you got to do in here. Just make sure it's connected. And there we go. Now in here we set the ledge parameters for angle, from angle. I'm not sure if in this, oh yeah, we were using motion warping, so that's good. So before I was using timelines. So I used to have this use saved act to transform in here, which is not going to be really needed for now. But as you can see inside of this function, I have this one, set ledge parameters from angle. So I have the delay until correction, play rate, starting position. So don't move if player. Don't move the player if no valid direction was found. We're going to use motion warping to correct the character's position on the ledge. So all you gotta do is just click here on the right click, go to the montage of the player, of the character going into the ledge that you want. And then on the notifies, go to 1. And then right click, add notify state and montage, motion warping. So click here on motion warping. And then you're going to have this window. On this window, you're going to choose a warp target name. I've chose mine to be ledge warp. We're going to use these values in here. Warp rotation. Don't ignore the z-axis. And you can choose these values. And here, it's very important to choose the motion warping to be where it should be. So the motion warping in this case, when the character goes up, as you can see, we have the root bone, which starts over here, as you can see. And then when it goes up, it goes up, it goes up. And then at this point, at the middle of the motion, we set the starting point in here so that the character can correct its position later. And then at the end, where the root bone reaches its final destination, the motion warping has to stop. So we just let it to be running a little bit more, and then we stop we place the endpoint. Now we're gonna have to do this with all the animations that the character goes into different directions. And boom, there we go. Now here for now what we're gonna do, if you don't have the motion warping component, we're gonna have to add one. So motion warping, add. In here, get the motion warping. What else? We get the add or update warp target, as we've done in this case. Here on the warp target, what you're going to do to get the little window in here, we're going to make motion warping target. So you can have the options to place in here. So as you can see, I have a different offset because it's required. I get the target transform, location or rotation. For the location, I add a little bit of offset for subtracting 87.5. If I put it to be like 1, oops. And then I try to play, as you can see, the character is gonna have a different offset when I go up, as you can see. When I go up, that's too much. Wait, what's going on? Oh yeah, because the name in here, oops. I haven't specified the name. So the ledge warp. So make sure that the warp target name is the same so that it works. So when you press on play, now the motion warp is going to work. If you set it to be 1 in here, as you can see, the character is not going to be in the right location. Yeah, that's pretty much it. On the component here, I like to set the capsule component to be set in there. And for the play montage, we get those parameters: play rate, starting position. Here is the wait time until allowing the character to go to the next ledge. Now this is a work in progress because I don't really know when. We're gonna have to set this up later. But for now, I just choose a retrievable delay, so the duration is 0.65. You can change it to be 1, for example. But if you try to go to the next ledge, as you can see, the character is going to be like this. It's going to be more responsive if you set it to be 0.1, 1 millisecond, but I don't recommend it because it allows the player to spam. So I just give it a little bit of time until we can go and we can allow the player to go to the next ledge. We just block the inputs, basically. And then here, after this delay, we update the ledge angle variable, which means that when you go to the next ledge, maybe the angle is different, so we just update it. So update the Boolean variable that the ledge navigation timeline is finished, or the movement of the character on the ledge has finished. Yeah, so I guess that's going to be it for this tutorial. It just it's not actually a tutorial. It's just more of a code explanation of what I've done to achieve this ledge navigation movement system. All right, so that's going to be it. I guess there's nothing more to explain. Just be sure to place such values such as this one. Can process input when the character is crouching. Just place this branch into here on the crouch inputs. For the aiming as well, it's very important to set this up. If the character is already climbing a ledge, for example, don't allow the character to crouch, the player to make the character to crouch. So if the character is climbing on the ledge, don't do anything. For strafing as well, I think this is toggle. Oops. So if the character is not climbing on the ledge, we can strafe. So that's going to be it. I hope you enjoyed. If you have any questions, you can comment down below. And I see you in the next one. Bye bye.